Learn something new? All right, so we're going to talk about today. We'll be looking at, we looked at cookies. I reorganized the code base, and that was like the homework challenge. You had that homework challenge right there to show visits. There's the solution. You had a lot of homework. And today we're going to be looking at sessions, and we might also look at HTTPS. And then there's a photo blog, which maybe we'll go through and look at how that works, depending upon how far we get. So that's what's on the docket. And the first thing we're going to do is we're going to look at sessions. And if you two are going to talk, I need you to sit in the corner. Or because that just like throws me off because, I don't know, my brain only has a single processing unit. And getting too many inputs, like multi-threaded tasks, multiple tasks, I start to overheat or something. Doesn't work.
To add to your RAM, I guess.
Yeah, I do need to upgrade my RAM. Get a couple more cores. Go to quad core. I've got 4 brains. How are you doing?
Good.
Yeah? All right, cool. So you ready to learn about sessions? Okay, what do you know about sessions? How do sessions work? Who can explain it? What is a session? We learned about cookies. What's a session in web dev?
Is a session the duration of time that you spend on a server or a website?
Yeah, so the web is stateless. So every request from a client goes to the server. The server fulfills that request, and the connection between the client and the server is done. That's it, done. Okay? And so if you want to maintain state, so state in programming is like there's some sort of state which is maintained. And if you're using Microsoft Word or something like that, it remembers, oh, this is who you are, these are the documents you opened last time. You close the program, you close the computer, you come back, open recent documents, I remember the documents you opened last time. Right? It knows who you are. There's a state to that program. Or a video game. You start a video game, you were on level 13, welcome back, pick up from where you left off. Right? There's a state to that video game. So that's state. My understanding of it, at least. People who've officially studied computer science want to chime in?
That's good.
All right.
So state would also be the transient state for like in the middle of a program. Mm-hmm. So like where the exact text of your document while you're editing it. But that'd be state as well, but it's more transient.
Yeah, so state is always changing. What is the state of this application in relation to this user at this moment? Right? And it's changing moment to moment as you're using the application. Okay, so that's state. The web is stateless, meaning it doesn't, in its design, the way it comes, it doesn't remember users. Okay? So that's stateless. A request comes in, fulfill it, done. Right? There's no connection, nothing. So if we want to maintain state, we have to build that in. So we talked about building that in. How do we build that in? I need some way to remember information about people. I need some way to remember information about people. And so clients are out there, unlimited, millions. If you're Facebook, 700 million. Right? People are connecting to the Facebook server. And Facebook has to remember who is each person. Right? So the way that is done is we're going to just give a unique identifier to each person. Okay? This is like the primary way. Give a unique identifier to each person. And we could store that in a cookie. And every time somebody makes a request to our server, since our server wrote that cookie, right? This domain, whatever it is, www.mcleods.com, wrote that cookie. Any request that client makes to that domain, when your browser makes a request to a client, when your browser makes a request to a server, a certain domain, it looks and it sees, do I have any cookies? Do I have any cookies that were set by that domain? And if it has a cookie set by that domain, it sends that with your request. That's just the way browsers, the web works. Okay, so if we write a unique ID in a cookie, anytime somebody comes back to our website, if they have a cookie with a unique ID, they send it back to us. So we could check, did a cookie come in? Does it have a unique ID? And if we have a unique ID, we know something. Right? We could store on the server all kinds of information keyed to that unique ID. it's like a social security number, right? The government remembers who you are. They give you a social security number, a unique ID, and then once a year, you send in some information to them, your taxes. And they look at it and they see the unique ID, the social security number, and they associate that with a certain account and with information which is stored in their storage systems, right? And they could see, okay, this social security number has this information stored with it. All you have to do is send them the social security number and they know stuff about you. So we need to store a unique ID in a cookie. And that will allow us to start to create a session. We have two choices for storing a unique ID. We have UUID. Well, actually, there's a couple of choices, right? So one way is we could just say, hey, I'm going to store a universally unique ID. And when you look at universally unique ID, UUID wiki, the odds, control your privacy and security, click your profile icon to access your Google account. Okay. The odds of somebody like, guessing a UUID, I'm just looking. I thought there was some analogy here. Only after generating 1 billion UUIDs every second for the next 100 years will the probability of creating just one duplicate be 50%. So for 100 years, generate 1 billion every second, and you have a 50% probability that you've generated a duplicate. So that's what a UUID is. Universally unique ID. So if I create a UUID and give it to somebody, the odds that two people got the same UUID, really low. Like I said, Facebook, 700 million users, I think. Facebook total users. Active users in millions, 1.5 million.
So that's
Total users, I thought it was like 1.03 billion daily users, whatever. So that's 1 second if they have 1 billion unique IDs. That's 1 second, which they'd have to do every second for 100 years, and then they'd have 50%. So that's one way we could give somebody a unique ID, a UUID. Okay, now, what is a security issue? What if I give somebody a UUID and we do that all HTTP versus HTTPS? What's the security issue? Yeah. So somebody could just be like using Wireshark and watching network traffic. It's HTTP, so it's not secure. It's not HTTPS. HTTPS is encrypted. It's secure. It's HTTP, so that text is just flowing out through the open. And somebody monitoring the network might be able to see, hey, that's your cookie. That's your universally unique ID. That's the thing which is the key to your account. I could then take that UUID, just create a cookie myself as if it came from that domain, or get a cookie from that domain, go in and edit the cookie, replace my UUID that was given with the one I saw on the network, and I'm logged into your bank as you, if it's HTTP, right? So that's a security hole. So the best way to do sessions is HTTPS. And that is actually HTTP 2, right? We're at HTTP 1.1. That's what everybody's using. HTTP 2 just came out when?
Just entered Go like a couple weeks.
Yeah, just entered Go a couple of weeks ago, but I don't know. We're doing Wiki because I think Wiki will just show it right on the right, like when it was released. But my resolution sucks. Here we go. Is this it? Done. HTTP 1. 2015, last call, HTTP 2.
The bottom
And
is
then
like
published HTTP 2, May 2015. HTTP 2, everything is HTTPS. So your whole site, HTTPS. Why? Why not? Right? It doesn't really cost much to encrypt it, send it, unencrypt it. That's nothing. Fraction of a second. So everything is encrypted, sent, unencrypted, HTTP 2. So when you create sessions, the main thing you want to do is HTTPS, okay? Because you don't want people watching your stuff. So you encrypt it all, and that just gets encrypted automatically. And I'm going to show you how to do HTTPS. So everything's encrypted. And then the next thing for creating sessions is you just need to give some unique ID. Now, there's also this thing about HMAC. So if you start looking into secure cookies and sessions, you're going to run into HMAC. So HMAC is a lot like this. Well, let's just go here. HMAC is a lot like this. What's that do? What's the checksum do? We looked at this, I think, right at the very beginning. What's the checksum do? Why is that there? What does it do? SHA-256 checksum.
Check it after you download it to make sure it's the same as the lock.
So I could download this software, and then I could run SHA-256 against that software. SHA-256 is an algorithm. So when you look into encryption, there's all these different algorithms which are kind of like black boxes. And you stick something in and something comes out. Who knows how it works? Right? If you take an encryption course, you'll probably learn some of the intricacies and intimate details of these different things. But basically, all you got to know is encryption, a lot of black boxes. You stick something in, something else comes out. So if I stick this software right here, the file I downloaded, into a SHA-256 algorithm, I'm going to hopefully get this number. If I don't get that number, it means the file they intended to send to me is not the file I received. Because when they ran SHA-256 against the file on their end, they got this number. So when I run SHA-256 against the file on my end, I should get that number. Take the same thing, put it into that algorithm, I should get the same thing out. All right? Now this is a really convoluted, right, jumbled thing, the stuff I get out of that, but that's what comes out. So HMAC is a lot like that. And with HMAC, I could take like the user's email and I could run a hash. So it's message authentication code is what the MAC part stands for, message authentication code. And H is hash, so HMAC, hash-based message authentication code. I could take like the user's email or whatever content I want to store on the user's cookie. I could run that all through some hash algorithm. I could store that number in the cookie with the data. I could send all that to the user, right? And then the user could send it back to me, and I could run all of that information again against that was stored in the cookie. I could run it back through my hash algorithm, and I should get the same number. If I got a different number, they tampered with their cookie. So this would be a way, if I don't want to store data on the server, right? Because with a server, UUID is fine. It's HTTPS. It's encrypted. It's secure. I send you the unique ID. It's encrypted. Nobody can see it, right? You send information back to me with the unique ID, and it's encrypted coming back, and I've got your unique ID. It's associated with you. There's a, incredibly minimal chance that it's duplicate with anybody, right? And then on my server, I store data about you. If I didn't want to store data about you on the server, but in the cookie, if I wanted to store data in the cookie, I want to make sure you don't change that data. So the data I'm storing in that cookie, I'm going to hash it all, get some number, store that data with the number, put it on your cookie, give it to you, and then you send it back to me with your request. I'll take the data that was stored, hash it all again, and I should have the same number that I stored in the cookie. They should match. If they don't match, then you change that data, and I'm going to say invalid. So that would be a way if I didn't want to store data on the server, but store the data associated with the client just in the cookie, which is not, I think, a good practice, right? Then I could do a hash just to make sure the data I stored is the data I got back, and you didn't change it. But I don't think that's the best solution. And then we'll also look at a third-party package, Gorilla, which allows you to use code somebody else wrote to do session management.
Basically, it's encrypted and HMAC cookies all in an easy interface.
Yeah. But I put together a little reading list here. That's the first thing. So this reading list, and FYI, if you're watching this video online, you could get to all of this code by going to GitHub, goes to 11, and Golang Web. So you get all that code there. I think GitHub needs a tip jar. And you could give me a tip. And I'm not talking about I could have done it better this way. They already have that. So if you look at some of these files, right, they talk about everything I just told you. And I've highlighted the parts which I think are cool. So if you're watching the video, you could just kind of take a gander at that, pause your video, and then you guys can watch this video later too. You could take a gander at that, and you could take a gander at that, right there. And that was the first one. And then the second one, and there's one here I do want to point out. So 2 ways to maintain session state: store session state, data about the client on the server, or store session state on the client, meaning in a cookie, right? So you could look at that and look at that. Storing session state data and cookies is riskier than storing it on the server. Why would anybody store session state and cookies, given that it can easily be stored on the server side? So those are nice. And then this one. So talks a little bit about signed tokens and HMAC, kind of what I just told you. There's a little bit more information. And for web applications, inexorably, you just want to use HTTPS for the reasons I told you. And then the last one I'll show you here. How do I protect session ID and cookies without using HTTPS? You have to encrypt the cookies prior to sending them. So that's where HMAC would come in. And you can HMAC verifies that it was not tampered with outside your server, right? So that's the piece about HMAC. If you want to encrypt your HTML stuff, then you want to do HTTPS is basically what that says. All right, I know that was just like a little bit of a fly through, but I just wanted to provide you those links for a little reference. So let's look at how we use it. So here's UUID. Handle func foo, listen and serve on 8080. And then request the cookie. We'll get a cookie and an error. If the error is not nil, there is an error. We're going to create a new UUID. And so you'll notice the UUID package I'm using is from new7hatch. So we could go to godoc.org and we could search for what? You're right, UUID. And then UUID right here, all the different packages with UUID. This is the one that was shown to us at Summer Web Bootcamp. I don't know how you evaluate the quality of one package versus another. You should be aware this is other people's code. So as such, maybe take a gander through it, that it's not doing anything you wouldn't want it to do, like creating a backdoor to whatever application you're building. But I imagine that this stuff is rated simply by how many people are actually using it, that they have some algorithm that just looks through GitHub and finds how many times is this there, and then the most popular at the top. That would make sense, right? I don't know. So here's UUID. If we look again at UUID on Wikipedia, we see that there's a couple of different versions. Version 1, 2, 3, 4, 5. MAC address, date and time, DCE security, MD5 hash and namespace, black boxes, black boxes, black boxes, stick stuff in, get stuff out, right? Random. A random UUID. And if we look at this right here, there's version 3, version 4, version 5. So those versions correspond to whatever the UUID specification. And if version 4 is the one we use, it just generates a random UUID. So we just use the function new v4, no arguments, and it gives us 2 returns, a pointer to UUID and an error. We can look at this example. UUID new v4 gives us a u4 and error. If the error is not nil, print the error. Otherwise, print the UUID, the u4. And I'm just wondering, like pointer to UUID makes me start to think about methods. And so string, variant, version are some of the methods there. String is a special method, string. Just like in Java, you got that string method, which when you print, if that string method's there, then when you print that object or whatever, it calls that string method. Same in Go, but different and better. Just always. Go is different and better than Java, no matter what it is. But, so that's why when I printed this down here, I didn't need to do u4.string because it has string right here. Okay. So that's UUID. So if I want to use this package, here is the namespace of that package, and I have to use go get to get it. So I'd copy this, copy that namespace, okay, and I'd go to my terminal, and I'd make sure I'm in my workspace.
Not needed.
Not needed?
Nope.
Oh, it's just totally.
It knows your Go path.
All right, and you could do go get -u, which will update it. You don't need the -u. You could just do go get, but I'm doing -u, and it's actually going to go out and update whatever I have, and it's going to go get that code. I think we did cover this because I said go get my repo, and it should have pulled down my whole repo. So you could have also done this with my code. So this is my code right here, and you could have gone go get, and it'd take that code and drop it into your workspace under the source folder, right, at this location. So you could go get anybody's code. Oh. And then in my workspace, under GitHub, since I went and I got that code, I have new 7 hatch, go UUID. And so that code is there ready for me to use. Cool. So that's package management, third-party packages, namespacing, like much easier than like Node, NPM, all that stuff. Node, again, Go is always going to be different and better than Node, no matter what the situation. So I went and I got my code. So now I could use that same namespace right here. I just say that package, and it's looking in my source. In my workspace, it looks in my workspace. So here's my workspace. Could have been called anything. Looks in source, and then it looks in GitHub new 7 hatch, GitHub new 7 hatch, go UUID, and now I have access to all that stuff I saw in the documentation. I have access to all these different methods and constants and variables. And so how am I using that? If there's no cookie, give me a UUID. And then, since I'm not printing here, I'm going to say give me the string of that ID, right? This is the ID. And then I'm saying give me the string of it. And that's going to be the value. The name will be session. Secure, you want to add this flag secure to your cookie. If we look at cookies, where do cookies come from? Cookies come from net HTTP, right? HTTP. So if we go and we look at cookies, type cookie. A cookie has a name and value. That's what we were working with last week. But it also has all these other fields in the struct. Okay? 2 of the fields are secure and HTTP only. Secure means that I am only going to send this cookie if I have HTTPS. Okay? So that's the only time this cookie gets sent, is when it's secure. So I set that to true, and this cookie will not be sent if it's HTTP. We're not going to play that game. And this is just a level of security. We only send cookies over HTTPS. So secure is true. HTTP only means that when the cookie is on the client, somebody else can't run JavaScript and access it. So only HTTP can access the cookie. That's the theory. But I don't know like how bomb-proof that is. I've never read any studies about is there some way to break that or get around it. But you could set it. HTTP only, JavaScript can't access the cookie. Anybody have any questions? All right, why have I commented it out?
Is it because you can only have one or the other?
Nope, you can have them both.
HTTP only says only HTTP or HTTPS. So, but
Yeah.
no accessing it from JavaScript on the client. It must only be sent to the server over HTTP.
Thank you. That's a very good distinction. So HTTP only means HTTP or HTTPS. Secure means HTTPS. So why have I commented it out? And then I set the cookie, and then I print the cookie, and then that's the end of this code, and you could read about the UUID here, and you can read about UUIDs there. Let's see it run. And I'm not going to comment it out. Change directories. 035, 02. You could teach old dogs new tricks. I've actually learned a lot about programming in the last 3 years. It's been pretty cool. I really enjoy it. And then go run main. By the way, go run is like shorthand. It's like the short way to get something to run. But go build, go install. When you have multiple files, you want to be using that. Okay? Like if I had more than main.go, go build or go install. All right, so that's running, and it's serving at 8080 localhost. And so when I come here, I didn't want to open it there. Go away. And I'm going to look at my resources and look at cookies, and there's a whole lot because that's Google. I'm just going to go to localhost. I don't have any cookies there. Let's try it again. Refresh. Hey, I got a cookie. What the heck? I wasn't supposed to get a cookie.
Yes. Yes, but it shouldn't be going back to the server. You are supposed to be using the cookie still. Are you printing the cookie on the terminal?
No, I think it is.
No, I'm not supposed to get a cookie. I don't know where that came from.
You have to choose one.
I'm not getting a cookie. Why is this code not working?
Well, what does it say in the terminal?
This is an HTTP.
Okay, let's look at the terminal.
Because you're not serving on the...
You're creating a new one each time.
Yeah, somebody just said it. I am at there's no place like 127.0.0.1. I'm at HTTP. When is the only time I send cookies on... I'm actually there. When is the only time I send cookies?
If you're on
HTTPS. Let's take this out.
Select 127 down below.
Oh, thank you. There we go. Did I have it selected before, or was that trickery? Let's confirm that.
Should run it again.
Yeah, I just wanted to clear that out. Yeah, so it wasn't trickery. It was weird we got one the first time. Not sure what happened there. But when that's secure, I don't get the cookie, because the cookie's only HTTPS. That's just kind of information, right? So that's getting a UUID. We wrote a cookie with a UUID. When it gets written, we now have this unique identifier, session ID. We set that on the client's machine. And then anytime the client makes a request back to the server, that comes back. And we can take this ID and we can look up information on the server. Oh, you're related. This is this person. Cool. Let's continue to explore UUID. So same thing. Request cookie. If error is not nil, meaning there's an error, get a new UUID. And this is not good practice, ignoring errors. So this is only teaching example code for keeping things more streamlined so you could focus upon the essential components and not have a big chunk of error to look at. But production code, you want to check your error. And then we create a new cookie and we put in the ID, and then we're just appending other data here. Okay? And we're printing that. What's the security hole with this? Let's see it run.
Is it oh wait, how is it appending the information? Is it just
I'm an 03 UUID.
Error is nil.
Oh, thank you. I got to get rid of my cookie. Okay. All right, my UUID is there, and then email, and some JSON data, and all kinds of stuff.
is that you
I put all that other stuff there. It's just a string, so I just concatenated it to the cookie. What's the security hole here?
Anyone can get our data.
Hmm?
Anyone can get our data and use it.
Yeah, so anybody could like figure out how do I edit cookies and edit this cookie and then send it back to the server. The UUID hasn't been edited, but if I'm relying upon that data that I've stored there for running my application, well, now the client can change that data. Who knows what they'll do with it? They might just cause an error in my server, but or they might find some way to compromise my system.
So hang on. Is the error that you are concatenating all that information to the cookie?
The security hole, you mean?
Yeah.
The security hole is, yes, I've added session data about a user to the cookie. The user can now change that. And I don't have any way of knowing whether or not the user changed that data. Okay? I don't have any way of knowing whether or not the user changed that data. So not good practice. This is not good practice. I should probably put that down here. Adding user data to a cookie with no way of knowing whether or not they might have altered that data. Okay. HMAC would allow us to determine whether or not the data in the cookie was altered. However, best to store user data on the server
And keep backups.
and keep backups. So one more example of UUID. This one's just getting rid of anything that's not coming in right there. So favicon or whatever. HTTP not found. Response request. Return. Request cookie session ID. If there's an error, it means there's no cookie. So create a UUID. Right. Session ID string HTTP only. If we got back email, request form value email is not nothing. And strings contains cookie value email, meaning the cookie value, which is a string, does not already contain the substring email. So if this, when I run strings contains this, it looks at the string, which is the cookie value. Is email in there? True. Okay, now make it false, right? So if this is false, and if this is,
Doesn't matter.
so if this is false, meaning email's not already in there, that makes it true. And if this is true, meaning email is not empty, meaning there's an email that the form sent in, and we don't already have an email stored in the cookie, let's store that email in the cookie. So take the cookie value, set it equal to the current cookie value, add the tag email, and then add the actual email. And again to this, right, I'm going to add these notes. This is not good practice. But that was just like, I don't know. We did it at boot camp. Okay.
So the purpose of number 4 is just to kind of automate adding user information to a cookie.
Yeah, just to sort of continue to provide you with more information about, if we wanted to actually, I think what happened at boot camp maybe was Caleb showed us this, and we're like, how would we actually get the email from somebody via a form? He's like, well, you do it like this. And so here, we're checking the form value. Hey, did we get it? Let's add it to the cookie. And here we're asking for somebody to enter their email. So it's not just like, hey, we made up an email and stuck it in there, but we actually got the email from user input. And hopefully this kind of stuff just kind of continues to show you things like HTTP not found, and we're only handling / not favicon here, since this catches everything, right? And we're doing something like strings contains, which is kind of an interesting or cool function to know about from the strings package. And then, write string takes the writer, the response. We're writing this HTML, which allows a form to be there. We're showing the cookie value if we have one, right? And that's a map lookup, so if it's not there, it's just an empty string. So the main takeaway is this is perfectly fine to the extent of my knowledge, and I'm no black belt web developer. Consider myself more of a brown belt. Okay, but this is perfectly fine way to create a session, use a universally unique ID, store it in a cookie, and just make sure everything is HTTPS. And then you could take that ID and you could associate it with data you've stored on the server. That's probably like the best way. And then HMAC is if we want to store data in the cookie and have some way of verifying that the data we stored has not been tampered with. So just like we use SHA-256 checksum to verify the downloaded file was the intended file, they run it and get this number, I run it, I get the same number, okay, cool. Right? We could do the same thing. I run some check against the data I've stored in the cookie, give it to the user sends the cookie back, I run that check again and make sure that the numbers are the same. If they're not, the user changed the data, because I'm now sticking something else into the black box and getting out a different result. So that's where HMAC would come in. That's my perspective on it. I asked JJ to do a little research and reading on it. Daniel knows some stuff about it. Do you guys have any other perspective on HMAC? But that's what I've gotten from the research I've done.
Not really well recommended. I mean, usually your server's going to have plenty of space to store data on. So you might as well store the data on your server, and that way you know they're not editing the data.
That's more secure way to store
more secure way to store, and it takes an algorithm which takes the other information like your email or password and secures it, and it validates the next time. So if the information matches, so it's good to go. Otherwise, yeah, there's something wrong.
Cool. So let's look at HMAC. Just for kicks and giggles. So there's crypto. Go has a really great crypto package. And I say this not because I'm a cryptography expert. I am not. I'm a cryptography newbie. I totally want to take like these 2 cryptography classes, which are on Coursera, right? I don't know if you guys have checked out Coursera or Udacity. Have you checked those out? How many people have checked out Coursera and Udacity? Cool. Like there's 2 really good-looking cryptography courses on Coursera that I'm interested in taking. So but what I've heard is that from other people, Go has a really great crypto package. And so part of this cryptography package is, you could do things like HMAC. And if you look at that, you do HMAC new, and then you give it like, okay, what is the hash you want to use? Let's use SHA-256. And then you give it a key. And so if you look at what the function new from HMAC asks for, it asks for here a function which returns a hash. Okay, so that's the type. That's what you pass in. And a key, which is a slice of bytes. And then it's going to give you back some hash. So just like, black box, stick something in, get something back out, a hash. I kind of think of hash as sort of like, you go out to Klein's truck stop at 99 in Herndon, or whatever the hell it's called now, and you get the breakfast hash, which always to me kind of looks like a whole bunch of crap just thrown into a pile. Like whatever, like some potatoes, some bell peppers, some onions. Right? It's just a big hash. It's a big mess. That's kind of one of the ways I think about hashes. There's some other, there's also like Amsterdam, right? They have a different kind of hash there, which scrambles things up, but in your head. So you get back an H, a hash, and then you write to that H. Write string takes a writer and a string. So you write to that, it's a writer. The hash implements the writer interface. You write to that, your data. And the data is whatever we passed in. So now inside our hash, that data got written in there. And we can do hash sum nil. And then that gives us some value. So we're just going to test getting a code off of a test email. We'll get the code, then we'll print the code, and we'll kind of see how black box, stick something in, get a random piece of crap out, piece of stuff out. So this is 05. GPO run. And notice if I change this, 1 letter. I change that 1 letter. So for those who are looking at their keyboards, it's test. I change 1 letter and I run that again. Completely different hash. So if I change the content going in, the output that comes out, totally different, even by the slightest change. And so if I wanted to compare whether or not, things are the same, I got to give it the same stuff. Okay, same stuff. Right? So if I'd sent that to the user, and then the user sent it back to me, and I ran it again, I had the same numbers, sweet, you didn't change it. So again, the get code, that hasn't changed. And now we're doing handle func foo, and listening and serving on 8080. And here's our foo and var code string, right? And then we're going to request form value email. So we'll have a form where people can enter their email, right? So we're saying, hey, if that's not nil, if that's not an empty string, then get the email, and then take that email and concatenate a pipe to it, not like a Unix pipe, but just like a delimiter. Concatenate this delimiter to it, and then add the code. So here's the data, here's the code, right? And then we're going to write that out if that is there. if the code is there. Otherwise, since I did var code string up there, when you declare a variable, you could declare a variable with shorthand notation which declares and assigns, so it initializes it all in one fell swoop. That would be like this. Okay. Declare, assign, initialize, all at the same time. This is only declaration. I am declaring that code, the variable code, is of type string. I've declared it. That's it. Right? So I declare it. When I declare something in Go using var, automatically gets set to its 0 value. The 0 value for a string is an empty string. You could read about 0 values at the Golang spec. Right there, they have a whole little section on it, the 0 value. And when storage is allocated for a variable, either through a declaration or a call of new, or when a new value is created, either through a composite literal or a call of make, and no explicit initialization is provided, so we didn't initialize, the variable or value is given a default value. Each of such a variable or value is set to the 0 value for its type, false for bools, 0 for integers, 0, 0 for floats, empty string for strings, and nil for pointers, functions, interfaces, slices, channels, and maps. So the 0 value is an empty string. So since I did var code string, code here is an empty string if there's nothing in it, which is fine to print out. No errors. So do you want to see it run? So before it didn't print anything out. When it had something to print out, it printed it out. So here's the data. And then here is the hash, right? And this is a hash message authentication code. So it's a code to authenticate a message, right? It's a hash-based code to authenticate a message. The message I'm authenticating is right there. It's HMAC, hash-based message authentication code. And if I change this, even by 1, watch the code, it'll change. So remember EE771, that's the last part. Now it's totally different. And if I go back to this, EE71, what goes in, always going to produce the same result. How many people have taken a crypto class? Cryptography, encryption. Put them up. 1, 2, 3, 4. Is it here at State that you took it?
I've taken back in undergrad.
Back in undergrad? Is it good? Yeah? You learn a lot of this stuff?
About the algorithm.
Huh?
About SHA and HMAC.
Yes.
You guys learn all the intricate, intimate details of it and how they work?
How they work and all that.
That's cool. All right. So here, get code's the same, main is the same, and then we're just saying if you're not just the default path, that's all we're doing. Have a nice time at work, Jose.
Take it easy.
Take it easy. And the name and then value, create a cookie, and HTTP only, and secure is commented out, but production code, I want to run everything HTTP2. I want to run everything HTTPS, so I'd uncomment that for production code. And so we write a cookie with no value if no cookie exists. And then we ask for the email, and if the email's there, then we're going to create a cookie value of email, pipe, and code. And then we're going to write that right here. So we set the cookie, and then we're just writing that as output. How's this different from the previous one? The previous one, I think I didn't ask for the. Oh, I did in the previous one. The heck? Main, var. So there is a lot more there. I did var code string, cookie. Okay, so some of the stuff that's different is I didn't do a var code string. I did cookie value. Right, so in this previous one, I just did code, 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 code. And this one, I'm integrating cookies. right? So there's no cookies on here. Command F, cookie, no cookie on that page. Okay, that was 06. 07, I'm actually saying let's use cookies. And so I'm writing the cookie, and I'm also showing the cookie value. Capiche? How many people are bored to tears? Raise your hands. How many people are learning something interesting that you think, oh, cool, good. So just make sure I don't have any cookies here. Get rid of that one. Clear all old lingering cookie. And then this is Voodoo Computing that I started a new browser window. So I don't think I need to do that, but I just did that because I have superstitions. Unfounded, like actions based upon unfounded beliefs that haven't been researched. So I should now have a cookie. You guys all have Voodoo Computing, don't you? You do a little Voodoo Computing every now and then, like you do something not because it's founded in like research, but because you just think, oh, because if I do this, then I probably won't get that. We could try it that way. So now I wrote that cookie. So I wrote a cookie with that value. Otherwise, same as before, showing it up here, but I've integrated cookies.
Don't feel bad about giving yourself data you're expecting to use. We do it all the time. This way you know when something went wrong with the data.
Yeah. Thanks. I appreciate how you guys have all kind of like, or a lot of you, kind of become like mentors also. It's been a mutual teaching relationship, mutual learning, mutually beneficial learning relationship.
I noticed that the cookie ID that you got for the test at example.com is the exact same one that you got previously.
EE71.
Yeah. So is it just what you're putting into it? Exact same text characters.
Yeah.
Well, the same email and in the code, he's using the same web per website code too.
Yeah. So part of the
So it's not like your browser remembering.
no. Yeah, no. So I could change this key here because this is part of what gets thrown into the hash, the big pile of breakfast mush which comes out once we put things in. Right? I could change that from our key to keys. And then if I ran this, so this time I won't do Voodoo Computing.
Your terminal, you just edited 08. Your terminal still in 07.
That value is the C pin, the L key.
It's a secret key to your website. That way, people can't just guess information, guess what your HMAC is going to be. If you just use SHA 256 by itself, anyone could just, if they had your email, could figure out the HMAC. So you got your secret key that's for your website, and that'll be added in to the SHA 256, and that way they can't just guess based on your email that you're using SHA 256 and get the same number.
Yeah, and this is, like on our server, that is the keys to our security and keeping user data secure if we're storing things in a cookie and we're using HMAC. So if we upload all this code to GitHub and it's public, people could look at that and then they could, say, well, let's just create the 10,000 most common emails. Let's create fake cookies and hijack all those accounts because they know how to create the IDs. You didn't realize you're going to learn to hack. But that's like part of, right, is understanding how you get hacked.
You never realize in any given day that you're going to learn how to completely destroy someone else's system. You just learn it.
So by adding that S to the R key, what did that do? That
Change the hash. It changed the hash.
Oh,
It is associated with that string. So if you change the string, you change the number.
So yeah, basically what it's generating, it's just doing normal SHA-256, but it's your email plus your secret key here.
Would you call that assault?
Yeah. Yes. Yeah, I believe official terminology is it's the salt.
So in encryption, right, the SHA-256, that's one thing we could run. And anybody could run that SHA-256. So when I do the golang.org download, right, this is how I'm able to download it. And then I just run SHA-256 too, and I can see if I got the same number. Cool. That's the way that's being used. That black box for encryption. Stick in the code. If I got the same number, the file that was intended is the file I received. Right? This one here, we're doing SHA-256, but this is part of HMAC. And HMAC not only asks for SHA-256, but some secret key, which also is a slice of bytes. And then it takes those two things in its black box and jumbles them all together to produce its output. Right? And then we use that to, you got to do these other steps here, take our data, which is a string, and write that to H, and then we do this sum nil, whatever the hell that does. Black box, don't worry about it too much. Right? You just put stuff in, get a jumble out. But the principle is what you need to understand is, okay, I could use this stuff to either, have some security. If our numbers match, what you received is what was intended. Or if I run this, here, and you're going to see that right now, I think in in 08, I've created auth, right, where auth is going to get the code that was sent back to me, which I wrote to the cookie. I'm going to recompute the code, and then I'm going to compare the two, and if they're not equal, the codes didn't match. So I'll show you how to break that, how that doesn't work. So let's look at that in action. Look at the code first. So get code's the same. Main, we got one more function here, one more path. So at authenticate, we're going to run a function called auth. And then we have foo, which anything which isn't here that ran in foo, we just give not found. And then if there's no cookie, we're no longer doing UUID. I think I could take that out. If there's no cookie, then session ID and value and secure and HTTP only. We create a cookie. And then if an email came in, right, we get the email and we create our value. And I didn't do that double check here to see, hey, is that already there? Right? We just say cookie value is equal to that. Up here, cookie value is nothing. Anytime a new email comes in, that's what cookie value is. Email and the code. And then we're going to just print that out so we could see it. We also set the cookie, right?
Always make sure you set your cookies before you start writing the body of your message.
Yeah, because what happens if you write the body first, which is here, and you don't set your cookie? Is that voodoo computing?
No, more
What
like
happens?
when you first write to the body, it calls write headers if it hasn't been called yet already in response writer. And because remember, your message is going back is all the headers separated by new lines, and then an empty line, and then your body.
Yeah.
So it has to have all your headers completely filled out before it starts writing the body,
And
which includes the cookie.
The cookie goes in the header. Sweet. Do you have any voodoo computing superstitions?
Not off the top of my head. I've got a couple, but not off the top of my head.
I think we need, what's that Jimi Hendrix song? Voodoo Child. We should do our own version, voodoo computing.
Are we talking about fixing test cases and stuff like that? Because if that's the case,
For me, I
then
clear up my cache
Yeah.
obsessively.
in that case, be very, very careful and make sure you cover all possible cases you're going to hit, or do some testing on your own with real data before you send
Yeah.
it out. Because if you've only ever fixed all your data you've ever gotten in, you may run into a problem.
Yeah. I think that's one of the cool things, though, is to build a site and try to make it as solid as you can and then see what happens. See what you overlooked. I built some cool stuff back in the day. I also think about some of the ways I built it, and I'm just like, oh man, that was such a bad way.
Now, you said to always set the cookies before the main body of code that details the cookie itself,
So
right?
no, you call set cookie to put it into the response before you write your
Your body.
HTML or whatever in the body. That's the body of the response. So same for headers. If you were setting content type, that would have to make sure you do that before you write your HTML or text or whatever. Just anything that would go in the header of an HTTP message, it has to go into. You have to write it before you write anything that would go into a body. So setting cookies is a part of the header of an HTTP message. So you have to make sure you put that in before the body, which would be here in this case the HTML.
Okay. Great questions, great dialogues, great contributions. Thank you, everybody. I really enjoy this process, and I learn something every day from all of you. I appreciate it.
So yeah, if you look in the code for set cookie, it's actually calling that headers function that we use for setting content type.
Right there. Right there. Any parents in here? You. Eunice, I mean, sorry.
Yeah.
Greatest joy you'll ever experience in your life. Having kids. But wait until you've got your education done, you have an income. Get that squared away, and then it's the greatest thing ever. And you have to be prepared to allow your schedule to be completely decimated. Because kids you can't do adult schedule. You just have to let that go. All right, so here's the auth. We request the cookie. So if we go to this page, authentication, right? We just say, give me the cookie. And if there's no cookie, you're back to the default page, so redirect. And is 302 what you'd use there? I got to read like a whole book on these response codes before I'll get it.
Yeah, 302 is that old deprecated one, but basically there's no difference between all the three major redirect ones if you're not using a form.
What would you use?
So I typically use 303. It's the other. So
Okay.
303 is defined as if you're sending me data in a form, I've processed it, go here for your actual HTML page.
Wait, hang on.
So, but since there's been no form, 302 and 307 do the same thing too.
I'm just going to do 307 then.
So 307 is officially defined as if you sent me data in a form, I did not process it yet. Send the data in the form to this URL.
So neither of those work, 303 or 307. It should be 302.
But since you're sending any data in a form, all three of them do the same thing. So like I said, it's an if.
Oh, so 302 is deprecated?
Yeah, it was originally meant to mean the same thing as 307, but it was originally meant to mean the same thing as 303. Everyone used it as if it was 307. So they eventually said, you know what, deprecate this. Here's two new ones, 303 and 307, with their actual official meanings.
What do you use if you're not doing a form?
Either one, don't matter.
Oh, it doesn't matter. So you would use 303.
Usually, yeah.
We're going to go with Daniel. He's the resident expert on HTTP codes.
I still have an excuse to use Teapot.
I think if I build an app, I'm going to drag some of you guys in, but we should have a path teapot that just like shows a teapot and sends that status. That's it. So and it'll be like what do they call those Easter eggs?
Yeah.
It'll just be an Easter egg. Like you go to teapot, you get status teapot and shows you a teapot.
Just have an excuse for that.
You are a teapot. That's what I'll say.
You can only use it if there's a really unique error.
Where's teapot?
It's in the 400 area.
Status teapot. funny.
They never removed it.
April Fools. All right, so redirect if there's no cookie, redirect if the cookie value is empty. Otherwise, we're going to take the cookie value and we're going to split it, and we're going to split it on a delimiter. Because remember, we had our data, and then we had the hash, and is delimited. When you split, it gives you back a slice of string, which is why that's XS. Slice is an X, S is a string. And then we're going to say, give us what's in position 0, which is the email. Remember, this is a custom application. It's the way we built it. And we're going to say, give us what's in position 1, which is the code that was received in the cookie. And then I'm going to get that. I'm going to run on the email received the code and get code check. And then this I'll uncomment just so I could change the email received. I'm going to add something to it. So it'll give us the wrong one as if it's been tampered with. And but right now it's should check out. Code received, code checked, not equal. Then they didn't match, and we print them out, and we do a redirect. And otherwise, we're going to say, hey, this is what received. That was what was recalculated, right? So it all checks out. So that's 08.
Yeah,
Yo.
Sorry, can you
Yeah.
scroll just a bit?
Show.
So when you split the
Yep.
cookie value between the email and the
Code.
so that means that at position 0 for XS, that's just the email.
Yep.
And at position 1, it's all the code that was after the pipe, I think it's called.
Yeah, because when we made the cookie, we put email pipe code. So then split just says find all the pipes, split it into slices on each side of each pipe symbol.
So we'll just show the slice, okay? That'll help you visualize it. Ah! It's going to submit something if I hit refresh.
If you hit refresh, it resubmits post request, but if you click the URL box and just press enter, it will not.
Oh, good. So session ID is nothing because I haven't put in an email. Put in an email. Submit. Now I have this, and then the pipe and the hash. So I've stored that on the user's computer. And I can validate that, and it validates. So received is the same as recalculated. Let's pretend that the user changed the cookie. And to do that, we'll have the email that comes back and add S to it. So it'll be test@example.coms. Control C, Control K, and go run main. And I'm go back, get rid of my cookie. Go back here and put in test. Submit. EE71, validate. Doesn't even let me go there, but if I look at my terminal, I'm printing that out. HMACs didn't match. So we're getting different HMACs. And we're also seeing the slice that, that's my slice. And notice there's no pipe, those are just entries. That's entry 0, entry 1, index position 1. So, cool. So again, the takeaway is UUID is fine for creating some unique identifier to stick onto a cookie to give to a client. Make sure it's HTTPS. HMAC is good if you want to do a message authentication code, so store things in the cookie and then make sure it wasn't tampered with when it came back. Those are the two different things you'd use those for. And then finally there's Gorilla, which is this. Control C that. How many people need like a 5-minute break? I kind of need a 5-minute break and reset. So we'll just leave that and I'll start a new video in this next one. And I think I need to try to find that song.